Welcome back. In this tutorial, we're going to look at 3 examples of things under free fall. So in all these examples, we are ignoring air resistance. So example number 1, how fast will a rock be falling after 5 seconds? And like always, we are going to identify what we know. I know how fast. I have this keyword fall, and I have 5 seconds. So how fast? That is a v equals question mark. And because it's falling, I know what a is. Things always fall at 10 meters per second on Earth. So that keyword fall is telling me this. And lastly, I have a time, 5 seconds. So for things falling, I'm going to use this equation, Vf equals Vi plus At. And I don't know what V is. I know A is 10 and T is 5. And this V naught is actually going to be 0. And the reason it's 0 is because this is falling from rest. So if you think about it, if you're holding a baseball and you have a slow motion camera filming you, as soon as you let go of that baseball in slow motion, it's going to look like that ball is not moving. As soon as you take your fingers off, it's going to look like the ball is floating for a very split second before it starts falling. So in reality, the ball actually starts at 0. It's not moving. As soon as your fingers let go of it, it's not moving, and then gravity takes hold of it. So this initial velocity is really 0. So we have V equals 10 times 5, which is 50 meters per second. Let's look at another one. Example number 2. How far will a rock fall after 4 seconds? So I'm going to do the same thing. I have how far. That is at x. I see this word fall because it's falling. I know A is 10 on Earth. And I have 4 seconds, that is the time. So because I have x and I have a, the only equation with both of those is this one. And for the same reasons, because it is dropped from rest, vi is just 0. It's starting from 0 before gravity grabs onto it and pulls it down. A is 10. I'm just plugging my numbers in. So x would be equal to 0 plus 1/2 10 times 16. So the 0 just goes away. I don't need it. And so I'm going to do half of 16 first. So the 10 stays there, and half of 16 is 8. 10 times 8 is, of course, 80 meters. There we go. All right, and our last example. For this one, a rock is thrown straight down at 20 meters per second. I want to find out how fast it's moving after 4 seconds. It is going to be falling. So there's actually 2 questions here. How fast will it be moving, and how far has it fallen? So let's do the fast first. So for the fast, I already highlighted it. We have a v of 20 meters per second. We're trying to find how fast it's moving. We have a time of 4 seconds, and it is going to be falling. So because it's falling, we know a is 10. So for this one, we have 2 v's, so we're going to use the equation with 2 v's. So we have v equals 20 plus 10 times t of 4. So you'll see that vi is 20. Vi is not 0. And that is because we're not just dropping it. It's not just starting from 0 and then falling. It is being thrown down. So our starting speed is 20. That's the speed. As soon as gravity grabs onto it, the ball is already moving at 20. So that's why that 20 is there. So we have v equals 20 plus 40, which is 60 meters per second. All right, let's do the second part. The second part is asking us how far. So let's get a little more room here. Actually, we could do it over here. So for how far, we're now trying to figure out x equals, all the rest of the information is the same. We still have b equals 20. We still have t equals 4. And we still have a equals 10. So it's using the same information, but this time we're trying to find an x instead of a b. So because of that, we're going to use this equation. And before I forget, this side is going to be for the how far. Okay, so our starting speed, once again, because we're throwing it down, our starting speed is 20. It is 4 seconds, so that's our t. And we have 1/2 10 times 4 squared. So that's going to give us 80 plus 1/2 10 times 16. And I'm going to do the same thing I did on the last problem. I'm going to do half of the 16 first. Get 8, and that 10 still stays there. So I get 80 plus 80, which equals 160 meters. And that is it. So basically, we're using the same basic kinematics equation, the same basic equations we've been dealing with. The only difference is, because things are falling, we have this A of 10, because gravity pulls things down at 10. The other tricky thing about these is to remember that your VIs will be 0 if it's dropped, or if it's thrown, VI is simply the speed it is thrown at. All right, I hope this video helped you out. If it doesn't, please feel free to ask me some questions. Thank you very much.